Waves come in two varieties, longitudinal and transverse. The difference between the two comes from the direction in which the particles move and the direction in which the returning force operates. If the force returning the particle to its original position is perpendicular to the direction the particle moves, then a transverse wave is produced. All the particles in the wave will move up and down, but the wave will move forwards. A transverse wave has two direction options. If you imagine a box, then the box can move in 6 directions in space. It can move up or down, it can move left or right, or it can move forwards or backwards. It is up to you which direction in your head corresponds to up, which left and which forward, but you can envision the idea that there are 6 directions in a 3-dimensional space. If you look at the scenario again, you can simplify it. Instead of 6 separate directions, you really have 3 directions and their opposites. The opposite of forward is backward, opposite of left is right, and the opposite of up is down. What's more, these directions are all perpendicular to each other, just in different directions. Up and down are perpendicular to left and right, and forward and backwards, etc. This means that a transverse wave can have particles oscillating up and down, and the wave could travel forwards and backwards, or left and right. A longitudinal wave doesn't have this extra bit of freedom. If the particles oscillate up and down, then the wave travels up and down as well. If the particles oscillate left and right, the wave moves left and right. If particles move forward and backward, then the wave moves forward and backwards. That is why the definition of a transverse wave is one where the oscillation of particles is perpendicular to the motion of the wave. A longitudinal wave has particles that oscillate parallel to the direction of the wave.